What if I told you that the universe contains places where existence itself is optional? Places where time doesn't flow forward, where space folds into itself, and where entire galaxies are being dragged toward something we cannot see, cannot stop, and cannot understand. Right now, Earth is safe. But the universe is not calm. Invisible forces are moving in the darkness. Ancient objects are waking up. And structures so massive they bend reality are slowly reshaping the cosmos. These places are real. They exist beyond imagination. And if Earth were even slightly closer to any one of them, human life would never have had a chance to begin. Tonight, we explore the scariest places in the universe. Places so extreme that physics breaks, time collapses, and reality itself begins to fail. When we imagine the universe, we picture stars, galaxies, glowing nebulae, and cosmic beauty. But the most terrifying regions of space are not filled with light. They are filled with nothing. Cosmic voids, often called the Great Nothing, are massive regions where matter is almost completely absent. These voids can stretch across hundreds of millions of light years, forming vast bubbles of emptiness between galaxy clusters. Consider the Bhuta's Void, a region so vast it was famously dubbed the Great Nothing upon its discovery, spanning over 250 million light years. Or the KBC Void, the largest identified void, which ironically contains our own Milky Way galaxy, suggesting we are already living on the fringe of the emptiness. To truly grasp this scale, imagine our entire Milky Way galaxy reduced to a single grain of sand. The void separating us from the next supercluster would be the size of a continent, a gulf of silent, eternal midnight. They are the largest known structures in the universe, a testament to the colossal forces that shape reality. Inside a cosmic void, gravity is weak. There are no stars to light the sky, no galaxies to guide direction, and no cosmic landmarks. If Earth were somehow transported into one, the night sky would go black. Not dark, empty. Even the Milky Way would vanish. The profound silence would be absolute. Every star that has guided human civilization for millennia would be gone, replaced by a suffocating, starless gulf. This complete absence of light challenges our fundamental perception of the cosmos. Scientists believe voids formed when gravity pulled matter into dense filaments, leaving behind huge empty spaces. But some voids are too empty, emptier than our models predict. This raises uncomfortable questions. The sheer emptiness of these supervoids defies the simple gravitational accretion model. Current simulations suggest a baseline level of scattered matter should still remain, but these megavoids contain far less, as if they were deliberately swept clean. Did matter simply drift away, or was it removed? Some theories suggest dark energy plays a role, pushing matter outward. Dark energy, the mysterious force accelerating the expansion of the universe, could be aggressively carving out these empty zones, expanding the voids faster than gravity can fill them. It is a repulsive, unseen hand, ensuring the perpetual emptiness of these regions. Others propose early universe fluctuations created permanent scars in space. These quantum ripples from the very beginning of time may have settled into these massive, enduring absences, foundational flaws in the structure of reality. Either way, voids reveal something disturbing. The universe is not uniformly alive. These regions feel less like natural formations and more like absence given shape. They are cosmic mausoleums, vast fields of non-existence that silently mock the vibrant activity of the galaxies clustered around them. They are where the universe forgot to be. And psychologically, they are horrifying. Humans evolved under star-filled skies. A universe without stars would feel dead, like the universe abandoned itself. The Eridanus supervoid is not just a void. It is an anomaly. Stretching nearly 1 billion light-years across, it is one of the largest and emptiest structures ever observed. Scientists discovered it while investigating a mysterious cold spot in the cosmic microwave background, the faint radiation left behind by the Big Bang. This cold spot appeared colder than physics predicted, as if energy had been drained from that region of space. The Eridanus supervoid sits directly in front of that cold spot, leading scientists to suspect a connection. Light traveling through the void loses energy, creating a chilling imprint on the universe's oldest radiation. But here's the disturbing part. This void is too large. Some physicists proposed radical ideas, including the possibility that this cold spot could be evidence of another universe colliding with ours during the early stages of cosmic inflation. While controversial, the theory reveals how strange this void truly is. If Earth existed inside the Eridanus supervoid, the universe would look painfully empty. We might never discover other galaxies. Humanity could believe the universe contained almost nothing at all. The Eridanus supervoid feels like a missing chapter in cosmic history, a place where something should exist, but doesn't. Hidden behind the dense dust of the Milky Way lies one of the most unsettling mysteries in astronomy, the Great Attractor. This is not a visible object, but a powerful gravitational region pulling thousands of galaxies toward it, including our own. Entire galaxy clusters are moving at incredible speeds in its direction, as if responding to an unseen command. The Great Attractor lies in the zone of avoidance, a region obscured by gas and dust, making it nearly impossible to observe directly. Yet its influence is undeniable. Scientists believe it may be a massive supercluster known as the Norma cluster, possibly embedded within an even larger structure called the Laniakea supercluster. But even this explanation doesn't fully account for its pull. Some theories suggest the pull is part of an even larger structure, the Shapley supercluster, which lies beyond the Great Attractor. The sheer scale of this cosmic structure is almost beyond comprehension, containing the mass of tens of thousands of galaxies. For decades, astronomers have struggled to map this region, battling the thick veil of our own galaxy's core that blinds our telescopes. It wasn't until advances in X-ray and radio astronomy that we began to piece together the puzzle. These new windows into the universe allowed us to see through the dust and gas, revealing the faint outlines of the galaxies and clusters that make up this immense structure. What makes the Great Attractor terrifying is inevitability. Gravity cannot be escaped. Over billions of years, our galaxy is slowly drifting toward this unknown region at a staggering 600 kilometers per second. We do not know what lies there, but something powerful enough to move galaxies is not something to ignore. The journey is long, and the destination remains a mystery. Will we be torn apart by the immense gravitational forces, or will we merge with the countless other galaxies already drawn into its embrace? The fate of the Milky Way and everything in it is tied to this silent, invisible force, pulling us ever closer to a cosmic enigma from which there is no return. At the heart of nearly every vast island of stars, including our own Milky Way, lurks a monster of unimaginable proportions. These are the supermassive black holes, cosmic titans millions to billions of times more massive than our Sun. Far from being simple voids, they are the gravitational anchors of their domains. In the bustling center of our galaxy, an object known as Sagittarius A holds everything together. Its immense gravity choreographs the grand, silent ballet of hundreds of billions of stars, pulling them into the familiar spiraling arms that define our galactic home. Without this central anchor, the structure we know as the Milky Way would simply fly apart, its stellar inhabitants scattered into the intergalactic darkness. Yet these cosmic behemoths are more than just passive anchors. They are active gardeners, shaping the very lifeblood of their galaxies. In some regions near the galactic core, the black hole's gravitational influence is a creative force. It squeezes vast clouds of interstellar gas and dust, compressing them past the tipping point where they collapse to ignite as brilliant new stars, creating vibrant stellar nurseries. But this same entity possesses a destructive side. When a supermassive black hole actively feeds, the material spiraling into its accretion disk heats up to incredible temperatures, unleashing colossal jets of energy and radiation that blast outward. These powerful outflows can sweep through entire regions of a galaxy, stripping them of the raw gas needed for star formation, leaving behind a desolate, sterile void. One of the most profound effects these giants have is their ability to warp the very fabric of reality. According to Einstein's theory of general relativity, massive objects bend space-time, and nothing in the universe is more massive than a supermassive black hole. This warping acts like a cosmic lens. As light from a distant star or galaxy passes near the black hole, its path is bent, distorted, and often magnified. This phenomenon, known as gravitational lensing, creates eerie and beautiful arcs rings, and even multiple images of the same distant object. More than just a visual curiosity, gravitational lensing provides astronomers with one of their most powerful tools, allowing them to confirm the existence of these otherwise invisible objects and accurately measure their staggering mass. While our galaxy's center is relatively calm today, the evidence points to a much more violent past. Extending tens of thousands of light-years above and below our galactic plane are two enormous, ghost-like structures known as the Fermi bubbles. These colossal lobes, glowing faintly in gamma rays, are believed to be the lingering echoes of a cataclysmic eruption from Sagittarius A millions of years ago. In that ancient era, our central black hole may have blazed as a brilliant quasar, devouring matter at a ferocious rate and spewing out energy on a scale that is difficult to comprehend. The Fermi bubbles are a stark reminder that these sleeping giants can awaken, and if ours were to do so again, the resulting surge of energy could have profound and unpredictable consequences for the entire Milky Way. Ultimately, when we zoom out from our local galactic neighborhood and observe the universe on its grandest scale, we see that supermassive black holes are not isolated oddities. They are fundamental components of the cosmic web, residing at the heart of nearly every major galaxy. They are not merely forces of destruction, but essential architects, intimately linked to the evolution of the cosmos itself. They govern the structure of galaxies, regulate the birth of stars, and drive a perpetual cycle of creation and annihilation that has unfolded over billions of years. These cosmic engines are a key part of the universe's grand, interconnected ecosystem, sculpting the galaxies we see today and shaping the future of the cosmos.